numerical differentiation. If here we will discuss about the numerical differentiation here. If the value of x is equally spaced, this value you can see difference is zero point 0.1, zero point 0.1 here, zero point 0.1 here, zero point 0.1 here, and so on. And if you want to calculate dy dx near the beginning of table, we will apply the Newton forward formula. And if d by dx is required near end of table, then we will apply Newton's backward formula. So these two formulas we will discuss here. If the d by dx is required near middle of table, then we apply the Bessel formula. And if the value of x is not equally spaced, and you want to calculate d by dx or d square y by dx square, then the Newton's divided difference formula will be used. So it means basically uh, uh, when you want the numerical differentiation, it can be uh, done on the basis of at which place in the table you want differentiation. So accordingly, the formula will be changed. Like here, if you want at the beginning, then it is Newton's formula, and if it is backward, then at the end, and middle portion is then the Bessel's, and if the it not equal spaced, then the Newton's divided difference formula that will be used. So here one example I have given. So this is the table, and the requirement is find dy by dx at and d square y by dx square at x is equal to 1.1 and x is equal to 1.6. You can see here 1.1 is here at the start of the table and 1.6 is at the end. So accordingly, we will apply the Newton's forward formula, and here at 1.6 we will apply the Newton's backward formula. Here the formulas basically you see carefully very small differences there. Here is the first case that x is equal to 1.1. Derivative using the this forward difference formula. Okay, this is the difference table basically, and here the operator is basically in the formula uses forward operator. We will see later on. You can see 1.1 we have to find. So try to draw a line here accordingly all these values. Meaning delta y will be 0.378 and del square y will be minus 0.30 and del square 3y will be this one, and accordingly del 4y will be this one. This is done basically you subtract this one from here, this is the answer, this one from here, this is the answer, this one from here, this is the answer. Now here you can see you subtract the 0.378, right, at the first entry, then second entry has 0.414 means 0.378 minus 0.414, that's why answer is minus. Here also it is minus you have to put. So wherever the positive is coming, here it is coming as positive quantity. You can see ahead in this table, this point it is positive because 0 minus 0.30 minus plus, so answer is 0.06. This way you can draw detail first of all, then we will see the formula. This is the formula. You can see 1 by h. 1 by h you can calculate, right? I have calculated at the start h is equal to 0.1. So you can put the value here, and then del this forward operator, right? Forward difference operator. So you can put del y. This value I will put that I have already mentioned. I have written here also, right? This one also. So you can write accordingly, right? Here x was 1 and x0 is 1.1, right? And the this interval is only zero point 0.1. Right? Accordingly, we can calculate the value which I have calculated on the in the first slide, I think. Del square y naught, del 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 square y naught here, del q y naught. I've already mentioned how it can be seen from table. So accordingly, dy by dx x naught. X naught I have written because it is at the start. So accordingly you can put 1 by h is 0 0.1. I put here, then del y naught, that is the value. According here all the values are put and the answer is 3.952. And the for the d square y by dx square, that is the formula. Here we will start from 2, del square y naught, here this one, then cube, then 4, 5. You have to remember these two formula. You have to remember these are basically Newton's power formula. So accordingly, we can calculate here the d square y by dx square at the start x0 equal to 1.1. Here 1.1, answer is minus 3.264. Here this is a forward difference operator. Here also you can see difference table. This is that is x is equal to 1.6. That is the formula derived using this uh, backward difference formula. So what you can see here, so because at 1.6, 1.6 is at the end, so accordingly draw the line here. That is the value of del y naught, ly, then the del square y, then del q y here, then del 4y, and so on. Accordingly, okay, you can see here now dy dx xn, because xn is at the end basically. In the first formula, I have put x0. Here 1 by h del y. Del, this is basically the backward difference operator. Only this is a major difference between the this Newton forward formula and Newton backward formula. You can see here accordingly this is the formula. You have to remember this, that this is a formula. H is equal to 0.1, as already said. Xn is equal to this 1.6, because I have h is equal to 0.1, because the if you see the jump from 1 to 1.1, then 1.2 is there, then 1.3 is there, then accordingly it means value of h is basically 0.1, because jump is only zero point 0.1, right? And you can write the values here from the table. At the end you have to draw a line to write all these values, then put other values here, 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 all values you can put. 1 by h is zero point 0.1, right? So all the value calculated and answer is here 2.75. Basically two, two, two things are you have to note, that when the differentiation is to be done at the start, then the Newton's forward formula. When at the end, so these two formula I have discussed, at the end is there, so that will be the Newton backward formula. And when the forward formula we are taking, so this operator will be forward difference operator, and at the end you take Newton backward formula, it is basically the operator is backward. That is major difference only. Then put other values and answer is here 2.75 here and 0 point minus 0.75. That was the case. Thank you.